Hi everyone, this is the introduction to logic, and we're just going to use some examples to describe logic. Logic is a way to describe situations or knowledge in a way that allows drawing new conclusions. It is useful in computer programming, artificial intelligence, and better understanding of language. You could also say it's good for debate and for lawyers, things like that. So, for example, all swimmers can swim fast. Daniel is a swimmer, so that means by logic, Daniel can swim fast. So that's basically what we're doing here. So we're going to write some propositions that are either true or false. I'll do some examples. That is true. Maybe like today it will be sunny. Tomorrow is Monday. Things like that. So that's a true proposition. Now, some examples that are not a proposition would be something like, let's have a party. It's not a proposition. And then like a question. Could you feed my cat, please? That's a question. That's not a proposition. All right. A negation of P. So if I say tomorrow will be Monday, a negation of P would be tomorrow is not Monday. And if you say, I like ice cream, then a negation of that would be, I do not like ice cream. So it's a statement, not a question. All right. A compound statement is a statement that's made of two or more propositions. So it's made up of two or more propositions. And now we're going to get into some properties of conjunctions. So basically, if we have a conjunction of Q and P, we can assume that today it will rain. Let's let P be, sorry about that. P be, today it will rain. And we could say Q is tomorrow, it'll be Monday. All right, and then the conjunction is an and statement. So when you see this symbol, it means and. So you're just going to say, today it will rain, or we actually want to do Q first. So we're going to say tomorrow will be Monday, and today it will rain. All right. A disjunction, Q or P, would be an or statement. So disjunction looks like that. And so we're going to assume P today it will rain. And our Q would be, tomorrow it will be Monday. So for Q and P, or Q or P, you're going to say tomorrow it will be Monday, or today it will rain. All right, exclusive disjunction is Q or P, but not both. So it looks like that. So we could say, let's see, we could do the same thing. We could say Q is today is, let me see, today it will rain is Q or P. So today, I'm just going to write the whole thing out. Today it will rain, or tomorrow will be Monday, but not both. So that's, when you see this symbol, that's exclusive disjunction. Okay, implication is your if-then. You're probably familiar with it in geometry. It's called your conditional, but we're going to call it implication. So for this one, we're going to say, if tomorrow is Monday, that's your P, then today it will rain. Okay, the converse means you're taking your, this is your hypothesis or your proposition, and this is your conclusion. So now you're going to switch it. It's kind of like Q, if Q, then P. So you would write, if today, let's say, if it rains today, then tomorrow will be Monday. So what you have to know for the logic is basically the vocabulary here. The inverse of an implication is just like your inverse of a conditional. So that would be, for example, if you have to use the word not. So you would say, let's say, assuming P is, today is cloudy. It is cloudy. And then Q would be tomorrow. It will be sunny. So there's your proposition and there's your conclusion. When you're doing the inverse, you're going to say not. So you're going to say, if today is not cloudy, then tomorrow will not Oh, how did I write that? So will not be sunny. Keywords here is not. And this is your symbol. Sometimes you see it as a tilde mark. Not P. If not P, then not Q. And the contrapositive of an implication is the opposite. So it's basically if not Q, then not P. So if we take our same Q and P, we could say, if tomorrow is not sunny, if tomorrow, let's write it as if tomorrow will not be sunny, then today it will not be cloudy. And finally, we have the equivalence. That means if two statements P and Q are equivalent, if P implies Q and I'm going to use this symbol, Q implies P. So if they're both true, we can say they are equivalent. So we could say if today is cloudy, then it will rain. So if today is cloudy, then it will rain. Then we could say if, I should put is cloudy. Let me rewrite this. Is cloudy. Then it will rain. Then you say if it rains, then today is cloudy. And basically what this means is if and only if. So you could also say if today is cloudy if and only if it will rain. Or you could say if it will rain if and only if today is cloudy. So that's basically also known as your biconditional. All right, and next video we'll go start the truth tables. Thank you. Have a nice day. Bye-bye.